Balancing a fan wall starts by defining the outcome, not by forcing every module to the same number. The project may prioritize total airflow, common pressure, uniform loading across a coil or filter, resilient standby operation, or power and acoustic limits. Those targets can conflict, so record the acceptance plane, operating mode, tolerances, and uncertainty before changing a command. Equal speed does not prove equal airflow. Parallel fans at the same RPM can see different inlet and discharge pressures because of plenum geometry, nearby columns, filter loading, leakage, or local recirculation. Wheel condition, manufacturing tolerance, motor calibration, and air density add more variation. Current, power, frequency, and percent command are useful diagnostics, but none is a universal airflow meter. Trustworthy balancing needs a measurement plan. Identify calibrated instruments, units, density correction, averaging time, grid or station geometry, and the exact system state. A single handheld velocity reading close to a fan outlet can be dominated by swirl and profile distortion. If software estimates module flow from pressure, speed, or power, validate that method over the intended range. Map the shared pressure field before applying speed offsets. Compare inlet and discharge plenum conditions by row and column, and inspect blank-off panels, bypass leakage, filters, coils, transitions, and casing obstructions. A physical bias should be corrected at its source where practical. Software compensation can conceal a blocked filter section or poor geometry while raising noise and energy. Treat the wall as one coupled air system. Increasing one fan changes common pressure and shifts the operating point of every other fan. Make documented, bounded changes, allow the system and sensors to settle, and compare matched condition trends. Preserve the approved baseline and rollback state. Chasing instantaneous readings one module at a time can create oscillation instead of balance. Protect each module while meeting the wall target. Monitor command and actual speed, current or power, temperature, vibration, alarms, and relevant pressure or flow. Do not push a fan beyond its manufacturer envelope, stable flow region, thermal rating, or permitted speed merely because total airflow is low. A balanced total is not acceptable if one module is overloaded or unstable. Verify control identity before diagnosing aerodynamics. Confirm that each command, speed feedback, power value, alarm, and sensor is mapped to the intended physical module. A swapped address can make fan 3 appear slow while the controller is actually changing fan 4. Use the approved point-to-point procedure. There is no universal register map, speed offset, alarm limit, or PID gain. Validate sensors and sequences as part of the same job. Check pressure pickup location, tubing, zero and span, filtering, flow grid condition, and communication quality. Hunting in a static pressure loop can resemble fan mismatch. Correct sensor in sequence defects before tuning individual modules, and distinguish stable offsets from transient behavior during starts, staging, or pressure reset. Plan isolation before any physical access. EC fans and VFD modules may have separate mains, DC buses, control supplies, stored energy, and automatic restart. Adjacent fans can windmill a stopped rotor, and permanent magnet machines can generate voltage. A stop command is not lockout. Use the equipment-specific energy control procedure, verified discharge time, zero rotation, guarding, and access boundary. A stopped module also changes the airflow network. It may become a reverse flow or bypass path, while an isolation or backdraft device adds opening pressure and leakage. Test standby and failed module behavior only under the approved change plan. Confirm redistribution, remaining fan limits, damper action, alarms, and recovery without exposing a live opening or removing a blanking panel under suction. In a data center or other critical facility, redundancy tests require authorization, monitoring, abort limits, and rollback. A conceptual model or approved lab demonstration is safer than intentionally failing production cooling for a video. Downstream coil or filter face uniformity may matter more than identical module flow, so judge performance at the plane that serves the design objective. Finish with a matched condition commissioning record across minimum, design, and maximum flow, authorized staging transitions, filter states, standby recovery, and communication or restart scenarios. Report total airflow and pressure, spatial uniformity, module status, speed, power, temperature, vibration, sound, trend stability, and measurement uncertainty. Good fan wall balancing is verified system behavior over time, not one perfect screenshot.